In this video, we'll take up the homework for radicals. So we have the first question. You have radicands of 3, 12, and 75. So 12 and 75 you can definitely simplify because 12 has a perfect square factor of 4 and 75 has a perfect square factor of 25. So that's basically my strategy for 1. I'm looking for perfect square factors to see if I can simplify. Yep, not much to say there. So for question 2, they wanted me to find a simplified expression for the shaded area in each shape. So for question 2a, it's a square in a square. So to me, I see like a donut, and I find the area of the big square and subtracted by the area of the little square. That'll give me the shaded region. For B, I find the area of the rectangle, subtracted by the circle, and I get the shaded region. Not much to say. Don't forget, area of a circle is pi r squared. For question 3, are the expressions solutions to the equation? So just do a left side, right side check. If left side equals right side, then it's a solution. If left side doesn't equal right side, it's not a solution. For question 4, a rectangle has a length of 10 and a diagonal of 18. Find the permanent area. So I need to find the width. So I drew the diagram, so x represents the width of the rectangle. You can add some markings here. Anyways, I have a rectangle, I want to solve for the width. Width ends up being root of 224, which simplifies to 4 root 14, because 24 has a factor of 16. And with the width, I can tell you what the area is, and I can tell you what the perimeter is. For question 5, they're asking me how to simplify root of 588. So using the fact that root AB is equal to root A root B, I can simplify that to 2 root of 147 because 4 is a factor of 588. For 6, a circle has an area of 63 pi. Find the radius. Yeah, so just punch it into the area formula and you can rearrange and solve for the radius. And of course, you have to simplify the radical. So root 63 works out to be 3 root 7. Last question, number 7 here. A square field is surrounded by 6-meter sections of fencing. If the diagonal length is 54 root 2 meters, how many lengths of fencing are on each side? So I basically solve for the side lengths of the square. So x squared plus x squared equals 54 root all squared, or 54 root 2 all squared because of the Pythagorean theorem. Because a square, a right triangle, using the diagonal. I solve for x. X is 54. Now because x is 54, that means I'm going to need 9 sections because each section is 6 meters. So 6 times 9 is 54. So I need 9 sections of fencing on each side. Okay, so that's the homework for radicals.